looks like photon somehow aware about the second open slit. It looks like it behaves like there were two of them, two photons. Okay, this sounds very strange, and we might ask a physicist how can we explain this situation. And we don't have a physicist here, so I'm going to act like one. I will reply that in this case, where photon can have different paths, or there are different points in space where it can reside at the moment, then we cannot discuss or consider such thing as a position or coordinate of a photon. Instead of this, we have to consider some probability distribution of position of this photon among all these possible paths. So in this scenario, in this experiment, we have to consider two paths when it goes through the upper slit and when it goes through the lower slit. So instead of one photon having one position at each point of time, we have to consider this probability distribution of its positions. And this probability distribution is called a wave function. And this is the real thing. This is what exists in the space when we run this experiment. Okay, then the second question to the physicist will be, what happens if we place a detector somewhere here? What happens to this strange wave function? Because what we detect is actually a photon, and it doesn't take two paths like this wave function does. And the physicist again will reply that if you place a detector here, then you make the wave function of this photon to collapse. So this wave function somehow understands in each point and each path that it has to collapse if we have placed this detector. Okay, now we are going to ask some clever question. If we have several quantum particles, a system of quantum particles, they all are described by the wave functions, what is the condition for them not to collapse? And the physicist will reply that the only condition is that the system must be closed. So it must have no interaction with the particles of some other systems. And when we place detector here, we break this rule. We introduce some interaction with this detector, and we cause the wave function of photon to collapse. Don't place the detector, and the wave function is going to be okay. Now, why this question is clever? Because now I'm going to take a very big black box. Let me draw it like this. So it is a big black box, and I'm going to place the whole system, the photon emitter, two slit screen, the detector, in this big black box. And everything inside of this big black box I'm going to call a closed system. For at least some period of time, this system here in the box will have no interaction with the outer world and even with the box walls. And I'm going to also introduce some intelligent observer inside of this big black box. And Schrödinger would suggest a cat, so let it be a cat. So, and the cat is inside of the box, so it is a part of a closed system. So the wave function of the cat must not collapse during the experiment. Now we train this cat to be surprised when it sees a flash. And we are going to run all this experiment inside this black box, and we cannot look inside of this box because it will break the rules of the closed system. But we can describe what happens there in the terms of these wave functions. So at some point of time, the photon emitter emits a photon, and now this photon has two different paths. It can pass through the upper slit or through the lower slit. I'm going to denote this like this. So this is upper slit, and this is lower slit. And please excuse me this premature notation. We are going to learn this in the next week. Now we will just denote it like this. Now I see some contradiction. For the cat in the box, the wave function of the photon is going to collapse because for the cat this is not a closed system. So the cat is either going to see the flash or not. But for us, the observers outside of this big black box, the wave function of this photon must not collapse because for us it is a closed system. Is it a nonsense? Actually not. When this photon reaches the interferometer of these two slits, then we have this situation. We remember that the cat has its own wave function. So we have a cat waiting for the entertainment, and we have these two paths of a photon. And then for the cat, photon chooses either the lower path when there is a flash and the cat is surprised. So this state transforms to a surprised cat. And a photon which pass through the lower slit, or the cat observes nothing because photons have chosen the upper slit. So please note, for us this state still preserves the wave function of the photon. So there are still two possibilities for the photon, and the wave function did not collapse. But the thing that happened is that the wave function of the cat has split, and now it is entangled, another unclear term for us by now, with the observation result. So instead of one cat waiting for entertainment here, we have two cats. One is surprised and one is not. And the interesting thing is that these cats do not observe each other. And if we place another intelligent observer, some observer here, and place everything in even bigger black box, so now this even bigger black box contains this big black box and an observer, and we instruct this observer to open the big black box and to look at the cat. Then for this observer here, the wave function of the whole system of inside this black box will collapse. So he or she will observe either the surprised cat or an ordinary cat. But for us, outside of this even bigger black box, nothing will collapse, so we will have an observer which observed surprised cat, which saw the photon coming through the lower slit, and we must have an observer which observed ordinary cat, which observed nothing. So for us, if we write the description of the system inside this even bigger black box, there are now two observers. And the question is, possible two questions here. Why these observers don't see each other? This is the first question. And why these cats don't see each other? And why the photons do? Because in this double slit experiment, we see this interference picture, which means that photons somehow aware about their possibilities. They are aware that they can take two paths. So this, the photon on this path here somehow interacts with this photon here. So they can add up and give us these black spots and maximas according to their phase. Well, the second question, why the photons interfere and cats and observers don't, is more or less clear. For these two parts of the state to interfere, we are going to need an exact match. If we have several parameters, for example, for one state, this parameter is plus, and for this part of the state, this parameter is minus, and the second parameter, for example, for this state here is minus, and for this is plus, then we have the exact match of these signs, plus plus minus and minus plus minus plus plus. And if we have this exact match, then these different states can add up. But if we don't have an exact match like this, for example, then they cannot add up. And for complicated systems, like an observer or a cat, the probability of having this exact match is very low, so they interfere almost never. Now, the answer for the first question, why these observers do not see each other, is less clear, and we are going to discuss this in the next episode.